We will explain in this new video a new class in our package of classes. It's to compare two population. It's out of the previous class. It was TSP frame. Here we have a new class. Let's run it by use the same configuration, debug compare population. So we have here a graphical user interface, and we will explain part by part. So the first part is here to select a file, an input file or a data file. So open a file. We have here the text file. Let's choose 30 cities. Open. We save the parties in text files. We will select the 3 numbers. We can here see that if we select now, we will have the city count to generate randomly. However, we need here to keep our data file. The tree count, let's use 3 trees, and here the population size, and let's use 1000. Using a upper bound or not upper bound. In first time we will not use the upper bound, we will use a normal generation of population. Let's make star. When we start, the population will be created and save as a name 30 city, the name of the data file, the input file, followed by the count of trees and the expression trees. What is mean? The initial population of generated by 3 trees in the file 30 point cities. We can here explore the data. The population by is a new thing. It's a new option. When the population is created, it will save as a dictionary. The dictionary contains like a hash table. Each a hash table is a data structure composed of 2 parts, the key and the value. The key in this case is the identifier of trees. However, the value is the population of this tree. Let's open this file, 30 cities.txt 3 trees point dictionary. Open. We will get here, here the path of the file, and here we have a set of our data. The name of read, the size of population, the best solution found, the average of the population, and the worst one. The average is the average of the three reads. Let's now try by another way. Let's try by using the upper bound. We keep the same configuration, but here the upper bound, we need to see where is the solution. So it's really complicated. We need to use like let's use it is like 2013. I don't know how much time can get it. For this reason I have some afraid about it. Okay, let's start. I think it's over. Here what we need to do, we will open a new file. I think his name is this one. Open, and we get another dictionary. By occasion, the name of file is the upper bound followed by the count of the file input file, the count of thread, and followed by the name threads point dictionary. We select it and we open, and we get the result here. And let's now compare between both. Compare. If the difference is negative, it means that T2 is better than T1. By case, we use the upper bound. It's approximately of the worst. So the size will stay the same. The best is approach and 12. It means that this solution, this random based solution, is better than the solution used the upper bound. It's like said, that is not really what we want. But the genetic process is a randomly process, so we can't choose, must have a best result. We can try with another example, we will get a result better. We compare here the average between both population, and we will see that the population based on upper bound is better than a random population. However, the worst is clearly some advantage of 35. Now let's try by another upper bound. Let's try by 2000, for example. I hope it will not take too much time. Okay, it didn't take too much time. Let's open this new file. In first example, we choose 2300, and now we will choose 2000. We have an update of result, and now we will make a compare. It's clearly here, we see it's clearly the result is too much better. We have about the best 60.67. In average we have like 50, and in the worst we have too much. The most important is to both best and average. The worst we will not care too much about. This is a sample. We can use some configuration like randomly, but we will not use 3-3, but we will use like more. We can make this comparison here. Okay, let's start it. I think it's over. So what we need to do, open, and we go search here. The 6th step, open. We will get, and we make a comparison. We can see that the comparison will be between the average and the average. And in this case, I see that using by 3 thread is better than the result take, but by 6 thread. That's just an example. It's not something that we want. Okay, maybe you can here feel, and you found that the result here is the better than here, but the most important is the average. We make here an average. We don't choose the best of best. Of course, if you use an example 23, then another 2 thread, 2 more chance to get the best in 23. Another option in this application, it's export. So what we export it, this table, we will write it in Excel file. We need to make here export. Here you need to be careful. You need to choose a file with the extension X1XLS. So if the file didn't exist, you should create it. Classer, open. It's over. Check your file. Okay, let's go here, let's search the file Excel and let's open it, and we can see that the result is the G table was created. That is better to write it in Excel and to use it later to make a new comparison. I don't know, everybody has some particularity to use this file. So I hope I did a good presentation. Sorry for my English, and I hope the next video will be better and the program will run much better. Thank you very much.